Holy cow, everybody. This is question 3 on the exam about equilibrium, and this is the titration curve problem. So let's spend a little bit of time going over this question, and I'm going to work through it again. I'm going to work through it just so everybody can see what it is, and this is going to give you, it's going to probably be another really long video, like the practice one that's 50 minutes long. I am going to shortcut a couple of the things, but we can go on from there. Okay, anyways, so let's start this problem. So let's do A. Okay, so A here, we haven't yet added any of the HCl. We only have NH3. So if that's the case, we don't have to do any stoichiometry step. This is equilibrium only. So if it's equilibrium only, we're going to do the base reaction. NH3 plus HOH is in equilibrium with OH minus plus NH4 plus. Okay, so what's the initial concentration here? Okay, the initial concentration is 0.050 ICE. Okay, this doesn't matter. Okay, get this all figured out here. Okay, so this is 0, this is 0, this is minus X plus X plus X, and so we can go 0.050 minus X, X, X. And so now to figure out what the concentration of the hydroxide ion is, we have to use Kb. So Kb equals 1.8 times 10 to the minus 5, because it's a base reaction. So that's going to equal products, X is really bad, X over, or X times X, over the reactants, 0.050 minus X. Okay, and so now we can simplify, and we can get rid of this guy, and this is squared, so this is going to equal X squared over 0.05. So now let's do a little math. So 1.8 times 10 to the minus 5 times 0.05, and then the square root of that is going to be 9.49. So in this case we have X equals 9.49 times 10 to the minus 4, and that is equal to the concentration of the hydroxide ion. Now that is not the pH, that is the POH, or that we can get the POH by doing the negative log of that. So the negative log of that answer is 3.02. And so that means that 14 minus that the pH equals 10.98, give or take. Okay, so that's the first step. So now we're going to add 30 milliliters for part B. Okay, so this is where it gets to be, I would say, fun. So for part B, we have to do a stoichiometry step first, and then we're going to have to do an equilibrium step. So the stoichiometry step, we're going to write a reaction. Remember, it's the acid plus the base, so it's H plus the base, NH3, it reacts with NH to form NH4 plus. Okay. There's a couple of variations. You could have HCl, the acid, plus the base, NH3, reacts to form NH4 plus Cl minus. That's the conjugate acid base. That's one. Let's see, then another one could be H3O plus. Because this is strong, we get H3O plus the weak base reacts to form NH4 plus OH minus. That's legit to write too. I'm going to write this one. Okay, it's just, this is what we have. Now when we do this, we need to do stoichiometry in moles. So let's do some stoichiometry in moles. So we have 30 milliliters of 0.05 molar. So that I'm going to do that over here. Let me put my calculator up here. Okay, so 30 milliliters, which is actually 0.030 liters times liter moles per liter, so that's 0.05 over 1. And so the number of moles of NH3, 0.03 times 0.05, is 0.015. And now the this is for NH3, and so now there's 30 milliliters of HCl, and so now we do the same type of calculation, and so that calculation is going to be 0.030 liters X line times, let's see, and then what's the concentration of HCl in moles per liter? The concentration is half of that, so 0.025. So if it's half of that, that's going to give you half probably of the concentration. So 0.03 times 0.025. And so this is 0.00075. Okay, so, and then this is 0. We haven't made that yet. So now we do our stoichiometry step, ICE, and so this is your limiting reactant, so it's minus all of this, so this is going to be 0, and so this is minus 0.00075, this is minus 0.00. That number is incorrect. I wrote it down wrong. Okay, 0.75, and then this is plus 0.00075. Now we do this. This is going to be 0.00075, and this is 0.00075. And so this is where we can say, well, this is half of the number of moles, so that's why everything is half. And so now we're going to do our equilibrium step. Okay, and so these concentrations now are equal. What is the volume here that we have? We have 60 milliliters, which is 0.060 milliliters, 0.060 liters. And so when we do our equilibrium step, we have to take the number of moles here that we came up with here and divide it by the number of liters here. So now let's do that Okay, so 0.00075 divided by 0.06, and so that concentration now is 0.0125 molar. Okay, so now we do our equilibrium step. There's only one ever equilibrium reaction, NH3 plus HOH. I'll write it like this so it's easier to see the transfer. So that's going to give us OH minus the conjugate base of water plus NH4 plus. Do a thing, do this, do this, do this. Okay, so now ICE, the initial concentration of ammonia is 0.0125. This doesn't matter. The initial concentration of NH4 plus is 0.0125. So now we do minus x, we do plus x, we do 0, we do plus x, and then 0.0125 minus x, x, 0.0125 plus x. So now we can solve for x. So KB, which equals 1.8 times 10 to the minus 5, which equals the products, x times 0.0125 plus x, all over 0.0125 minus x. Yeah. And so now, in a different color, these two things cancel out because of the 5% rule. And so now we have these two things are equal to 1, so we get x equals 1.8 times 10 to the minus 5 molar, which is also equal to the concentration of the hydroxide ion. But now we don't need the hydroxide ion, we need the pH. So the pH of this, we first have to find the pOH, so we do the negative log of 0.0125, and that is 1.9. Oh, dirt. It's not that. It's the negative log. See, this is the problem. These problems are so in depth that you can do something very similar, very silly, and then it screws up everything else. It's the negative log of 1.8 times 10 to the negative 5. And so now that is, so x, so now this is pOH equals 4.74. So that means that the pH equals 9.26. So that is cool, and that is the pH at the halfway point. Okay. And notice the difference between these two is that the pH hasn't changed much. Okay, so now part C, the pH between, sorry, go back. The pH between 10.98 and 9.26 hasn't changed much, even though we've added 30 milliliters of a strong acid. So now we're going to do 59, 60, and 65. So let's do 59 milliliters. So again, we're adding 59 milliliters, so that's our stoich step. Okay. And in order to do stoich, remember that, I'll go back to black here, this needs to be done in moles. And so our stoichiometry step should be the same as our first one. So we're going to have H plus NH3 reacts to form the base NH4 plus. And any one of those, any of these will work as well. Okay, but it's always the acid plus the base. Okay, so now we need to convert to moles. So now this is still the same, ICE. This is still the same. This is still 0.0015 because that's still 30 milliliters of 0.05 molar NH3. But what's changed is now we have 59 milliliters of the 0.025 HCl. So now we're going to take 0.059 liters. We're going to X-line it, so we're at liters, mole. So we have 0.025, and so now we do 0.059 times 0.025, and so now we get 0.001475. We don't have any of this to begin with, and so now we do our stoichiometry. What's the limiting reactant? Well, the limiting reactant is this guy. That's the whole point, is that it is the amount that we use up all the strong thing, and all that's left is the weak. So we're going to use up all of this. This is going to go to 0. So now here we do minus 0.001475. And then this is going to be the same thing, minus 0.001475. And this is plus, because we're making it 0.001475. And so now this is where it gets totally crazy, is that this concentration is 2.5 times 10 to the minus 5th mole, not concentration, that number of moles. Okay, I put that in scientific notation. And then this number of moles is 0.001475. Now that's moles. Now we need to know how many milliliters that is. So it's 89 milliliters. We have 30 and 59. So this is divided by 0.089, and this divided by 0.089. Okay, so now change color, because we're going to need those two things. 2.5 times 10 to the negative 5 divided by 0.089, and that equals 2. This is 2.81 times 10 to the minus 4, and then this is 0.001475 divided by 0.089, and this is 0.0166. These are both molar. So now we're ready to do our equilibrium step. Oh, whew, this is long. Not 50 minutes long, but definitely long. Okay, so again, remember, equilibrium reaction doesn't change. Let me do equilibrium. Okay, so this is NH3 plus H2O is in equilibrium with H3O plus N. Oh, see? I get lazy, and then I think this is a base reaction. So this is going to be OH minus plus NH4 plus. Glad I caught myself. Okay, so now we do our ICE chart. Okay, we use our values that we just determined from our stoichiometry step. And so now this is, how much of this do we have? We have 2.81 times 10 to the minus 4. This doesn't matter. This we don't know. And this is 0.0166. So this is minus x plus x plus x. And so this is 2.81 times 10 to the minus 4 minus x. This is x, and this is 0.0166 plus x. Whew. Okay. Crazy, crazy. Okay. Not done yet, because now we have to go KB equals, and remember that's 1.8 times 10 to the minus 5. And that equals products, x 0.0166 plus x, that's another product, over the reactants, 2.81 times 10 to the minus 4 minus x. And so now with this, we are going to take, and we're going to get rid of these because of the 5% rule. Okay, and so now we solve for x. So we can get x equals, and so now we do 1.8 times 10 to the negative 5 times, because we want to multiply this up, times 2.81 times, oops, not times, times 10 to the negative 4. And so then we take that and we divide it by that. So divided by 0.0166. Okay, so now we get x is 3.05 times 10 to the minus 7 molar, which equals the hydroxide ion concentration. Now we do the POH of that guy. Okay, POH, which is the negative log of this, so negative log of the that. And so the pOH is 6.52. And so that means the pH is 14 minus that. So 14 minus that is 7.48. That's your pH. Okay, and so now we're approaching the equivalence point. And so if we're approaching the equivalence point, well, we can do some things. But anyway, so we'll do that. So now we're going to do, so we did this one now. So now we're going to do 60 milliliters. Okay, so now with the 60 milliliters, that should be right at the equivalence point. So now, so again, okay, I can't say it enough. Same reaction. So it's the acid plus the base reacts to form the conjugates. Okay. So now let's do our stoichiometry ICE chart. So this is our stoich, and remember our stoichiometry ICE chart is done in moles. So our mole calculations over here, we still have the same 30 milliliters of 0.05 molar NH3. So that's still going to be 0.0015, right? 0.0015. What's going to change is this. So for HCl, we have 60 milliliters of that. So 60 milliliters of that is going to be 0.060 liters. X-line it, liters on bottom, moles on top, and it's 0.025 moles for every 1 liter. And so we do that math, 0.06 times 0.025, and so now we get that is 0.0015 moles. This is 0. So now we find the limiting reagent. Now the neat part about this is because this is at the equivalence point, this and this are both the limiting reactant, and so that means that we are going to add 0.0015 to this, and we get 0.0015 is our concentration of NH4 plus. Okay, I guess in this case this is minus 0.0015 minus 0.0015. So this is letting you get through all that. Okay, so now here, this is the interesting thing. This is now not a weak base problem, because there is no weak base. There's none of this left. Okay, it is a weak acid problem. So if it's a weak acid problem, now we need to figure out how to do this. So not how to do this, but we need to now change up our mind set. So this is going to be NH4 plus H2O is in equilibrium with, let's see, H3O plus NH3. And so now we're doing the acid part of the problem. ICE. Oh, and guess what? We still haven't done the concentration. So 0.0015 divided by 90 milliliters, which is equal to 0.090. So that divided by 0.09, and so so the initial concentration of this is 0.0167. H2O doesn't matter. We don't have any acid, and we don't have any of this. How do I know we don't have any of this? Because look, none of that left over. So if we don't have any of that left over, that means that it's not there from the stoichiometry step. Okay, so this is minus x, this is plus x plus x. So this is 0.0167 minus x, x, x. Now, we were given in the problem a k, we were given a kb, but this is, we don't want to use that because we need a ka. So we know that kb times ka equals kw. So 1.8 times 10 to the minus 5 times ka equals 10 to the minus 14. And we'll put a 1 in there. 1 times 10 to the minus 14. Okay, make sure that I don't move my calculator out of the screen. Sorry about that. So I'm going to go 1 times 10 to the minus 14 divided by 1.8 times 10 to the minus 5. And so Ka equals 5.56 times 10 to the minus 10. Whew, half the time. Okay, right? We have 30, we're at 26 minutes. Okay, and that is equal to products x times x over reactants 0.0167 minus x. Okay, so now change color because we're going to assume that this is out of there because of the 5% rule, and so now we're going to solve for x. So this reduces to x squared over 0.0167, and so now we do this times 0.01667. Okay, it was 0.016 repeating, so it's okay how many sixes I put in there, that's fine. Okay, so that's that. Now we do second square root of that answer, and so now we get that this is 3.04 times 10 to the minus 6, which is equal to x, which also equals the hydroxide ion concentration. Okay, so now we can do the POH, which is the negative log of that, guy, which is 5.52. And so at 5.52, so that means the pH is equal to 8.48. Okay, so there is that. Okay, so now the last one. Now we're at 61 for part E. Let me do this. We're doing 65 milliliters of HCl. Okay, and this one isn't going to take as long. So now we always do a stoichiometry step. As my voice cracks and I finally hit puberty here. Stoichiometry step, we're going to do it in moles. So we're going to keep the same reaction that you've been using. H plus NH3 reacts to form NH4 plus. Okay. So we have ICE. Okay. I'm just double checking. I'm trying to figure out. Yeah. I think somewhere I messed this up. This problem right here. 9 times 10 to the minus 12 square root the negative log .48 pH. Oh, that's where I screwed up. Look at me. Okay. This is not the pH. Here, it's already hydronium ion, H3O+. Oh my gosh. Okay, so this is already the pH. We don't have to do that. This is your pH. Okay. Whew. Okay, my brain is getting scattered. Okay, now for the last one. Okay, this is H3O. See, we flipped it. When we flipped it, we had H3O plus already in there, and we were doing A, so this is actually the concentration of hydronium ion, and then that's going to be 5.52. Now, moles. Let's go to E now. E, 65 milliliters of HCl. So this concentration, just like everything, is still, we still have 30 milliliters. So this is still 0.0015. But now for HCl, we have 0.065 liters times, and then we want moles on the top and liters on the bottom. So this is 1 liter, and this is 0.025. And so now we do that math, 0.065 times 0.025. And now this is going to be 0.001625. Okay, so now from there we can do this. Let's see. So this is going to be 0, right? This is going to be the limiting reagent here. This guy. So that's the thing that's going to be 0. So this is going to be minus 0.0015 minus 0.0015, and then this is plus 0.0015. And so now we have, this is 0.000 do math, Walsh, 125. Okay, and this is 0.0015. So now we can go and do a ICE chart with this, but we need to do the concentrations of this. So this is divided by 0.095, 0.095. Okay, so now we divide, we do 0.000125 divided by 0.095. Let's do that again, except 0.95, because that's the volume. And so now the concentration of H3O plus, the acid, equals, at the beginning is 0.00132, and the concentration of NH4 plus equals 0.0015 divided by 0.095, and we get is equal to 0.0158. So those are molar, so that's good. And so now we can do the equilibrium where we get NH4 plus H2O. This is our acid now, is in equilibrium with H3O plus NH3. Whoop, whoop. Okay, so this is that. Okay, let's see here. This is going to be 0.001132. This is 0. This doesn't matter. This is 0.0158. So this is minus X plus X plus X. This is 0.0158 minus X. This is 0.00132 plus X. This is X. Okay. We're in the final one. So we know that Ka equals 5.56 times 10 to the minus 10 from part D, right? Okay, yes, 5.56 times 10 to the minus 10, and that equals X over 0.00132 plus X, the products, over right? Products over the reactants, 0.0158 minus x. Okay, and so now we can take this thing here, and we can, that's the cancel out with the 5% rule. So now we can solve for x. Okay, we're going to multiply by this, divide by that, and make sure that I don't make the same mistake that I made in the previous part, part D. So 5.56 times 10 to the minus 10 times 0.0158 divided by 0.0032. Okay, so this is x equals 6.66 times 10 to the minus 9 is equal to x. Now that we have x, we can take the value that we had. Now this is where it's different again, is that we have to add that to this. Okay, so now it's 0.0013 plus 6.66 times 10 to the minus 9. Okay, so now we go 0.00132 plus, and now this is the funny part, is that this is still going to be 0.00132, but I will add it just to show you, times 10 to the minus 9. And so, see, it rounds to that value. Okay, so it's going to be 0.00132, which is a chemical principle that the strong acid, or the strong component, will completely outweigh or completely out pH the weak component when you have a mixture of acids. And so if that's the concentration of hydronium ion, then you do the pH of that. pH equals the negative log of that. And so now we get an answer of 2.88 is equal to the pH. Okay. So, there you have all of that. Whew, it's a long time.